Okay, so we're going to be looking at solids whenever we increase the lengths within that solid, see what happens to its lateral surface area and volume. So look at the example here. I have a cylinder with a radius of 3 and a height of 4. What do you think the cylinder would look like if you doubled its radius and its height? It would probably look something like this. You double the radius, it gets 6. You double the height, it gets 8. What do you notice about these two cylinders? Well, because we doubled both lengths of the cylinder, their lengths are proportional, meaning that these two cylinders are similar to each other. Even though they're three-dimensional, they are still similar because all of their lengths are in proportion. Okay, so let's use our formulas to find the lateral area of the original and the volume of the original, and we'll compare it to the new one. So for lateral area, we have pi times diameter, which is 6 in this case, times the height, 4, which will give us a lateral area of 24 pi square units. For volume, it's pi r squared times h. So we would have pi times the radius squared times h, which would be 4. So that would be 9 times 4, which is 36 pi. Okay, so what do you think the lateral area of the new cylinder would be? Let's see if your prediction is correct. So we'll apply the formula, which would be pi times the diameter, which is now 12, times the height, 8. 12 times 8 would then be 96 pi. Okay? Now, what I would like for you to do is to compare the original lateral area to the new one. How do we usually compare things? Well, since these two solids are similar to each other, we need to look at their ratios. A ratio, again, is just comparing two quantities. So let's take a look at that. If I were to compare the ratio of the lengths, first of all, I notice that it's 3 to 6 and 4 to 8, so the ratio of the lengths is a 1 to 2 ratio. Now let's take a look at the ratio of the lateral areas, or just areas in general. So ratio of lateral area. If I were to take 24 pi over 96 pi, 24 pi over 96 pi, and reduce that, what would I get? I would get a 1 to 4 ratio. Okay? So, what if I looked at the volumes? So if I look at the volume, I'm going to put this right here. It would be pi r squared, so 6 squared, times the height, which will be 36 times 8, and 36 times 8 is 288 pi. Okay, so now let's compare the volume of the original with the volume of the new. Okay, so let's take a look at those ratios. So if we look at the ratio of the volume, we are looking at 36 pi over 288 pi, And if we reduce that, that will equal 1/8. So look at these different ratios, the ratios of the lengths, the ratios of the areas, and the ratio of the volumes. What seems to be happening? Well, some people would say that you're multiplying by 1/2 each time. Well, what does that really mean? We'll take a look in the next video.